NuNet is a decentralized computing platform, and I saw this one in a Project 7 Catalyst proposal, and it was talking about how you could possibly decentralize the computing power for stake pool operators. So instead of buying resources from AWS or DigitalOcean, Linode, whatever it might be, you can use people's computing power, such as this giant computer that's next to me here, from someone's home, and use that instead to power the stake pools. And I thought this was a really cool and interesting concept, and I want to explore it a little bit further. And I have Dr. Kabir Veitas join me on this episode to talk all about the platform, to explain it in detail. And I threw him some really hard questions in here, so I got him to go through and answer these for me, because I could potentially want to run a stake pool or at least a relay off this platform, especially if it's cost effective to do so, or even run websites off it. I run a web design agency, and to have a different option as opposed to AWS to run websites on is really appealing. So I really want to dig deep and work out and find out how exactly this platform worked. And thankfully, Dr. Kabir could talk all about it, explain it all, and I have this interview that will hopefully explain it all to you as well. So if you like this type of content, please consider giving me that thumbs up, click subscribe, and click on the notification bell, and you hear more great Cardano content from me. Let's get into this interview.
Yeah, gotta do it like that. You've been listening to the Learn Cardano podcast.
I have Dr. Kabir Veitas joining me on this episode to talk about a project that popped up on my radar through Project Catalyst. It's called NuNet. It's a little bit different. I hadn't really dived deeply into this one, but I have the doctor here to talk all about it and explain to us exactly what's going on. Dr. Kabir, welcome to the podcast.
Thank you. Thanks for having me.
Okay, so I'd like to just dive into your crypto journey first and how you actually got to this point where you're building out NuNet. When did you first jump into the crypto space, and how on earth did you come to this decentralized computing on NuNet?
So for the first question, I think when Ethereum was $25 per Ethereum, I don't even remember when that was. Not that I but basically, this is when I think I started to at least, but the price is just an indication, because I got interested in blockchain from the computer science perspective. Basically, this is where I come into. This is what is most interesting for me, and this is from where I came into crypto world. Let's say, got interested in, of course, the Bitcoin paper in 2008. So this is. And mostly so the way that crypto, let's say, started to interest me is pretty much from the perspective of decentralized computing. And basically what the Bitcoin paper did, they solved the kind of this Byzantine generals problem from the game theoretical perspective. And that is the beautiful thing about this. And then it started all the movement. So yes, I'm interested both from the computer scientific perspective to how that sort of different technologies got converged, and then how does that influence social, let's say, the socio-economic development, which is still a promise, but I think we have quite a few milestones within this movement already passed, and then some other milestones to be passed. So this is my basic sort of general interest in the space. And then, of course, then comes all the other things that sort of comes with the crypto. Now, the second question, where does NuNet come in? Pretty much through that perspective, because NuNet is a decentralized computing framework, which is not necessary. I mean, it's basically blockchain agnostic. So blockchain in general, and blockchain in general, this technology allows us to do certain things like microtransactions or smart contracts or agreements, let's say contracts between machines to machines, pretty much something that we were even not having this technology before that, while we had this idea of decentralized computing. So this is where NuNet comes from, or maybe comes in. So we are using the technology in order to allow decentralized computing, which is basically off-chain. And we're looking for to combine different blockchains and different technologies to make that available. And what we're building a global decentralized economy of computational processes or computing. So this is what NuNet is all about.
Which is absolutely amazing. I've heard of decentralized computing before. I can't remember when it was, but a very long time ago, I used to use my computing power for folding, and I can't even remember what project that was for. It was like a medical research. I can't remember. Maybe you can spark my memory, but I think that's
protein folding, 3D like structures of proteins, which was running through Boeing, which is the most most successful distributed computing framework.
Yeah. So does it borrow principles from that? Is that this like a similar kind of thing? I'm just trying to find something else that is very similar that I may have had exposure to.
So, as with all these things, there are similarities and there are differences. So, I mean, usually the way we kind of distinguish these things is that there is a distributed computing and there is a decentralized computing, and basically as everywhere. So, distributed computing, I think it started with maybe MapReduce algorithm, but basically that you have centralized agent which distributes computing to sort of compute workflows to many sort of computers and make that parallelized. So basically GPUs are also kind of does that. However, decentralized means there is no central point. That those computing processes, they interact with each other and kind of agree on what they're exactly doing by themselves without some kind of central point or central entity defining what each of them have to do and then collecting the results. So the folding at home was distributed and is distributed. Now, decentralized is a kind of step forward, which makes abandoning the idea that somebody directs everything in the network. However, in general, for each process, you will have some kind of master node which orchestrates the process. The main difference here is that these master nodes are not predefined. They find themselves depending on the process and depending on the demands. It's a little bit similar, I think, what we're doing in the concept with initial concept of decentralized autonomous computing, the one that was proposed by Vitalik Buterin in the very beginning of Ethereum, which is basically how algorithms will autonomously build a corporation. So build workflows.
Wow.
Now, so I think, basically that is, I think, the closest thing.
Okay.
And at certain point, Ethereum was considered like global computing or engine. However, I think it diverged from there. It was within these few years. So, the years that they're developing.
So I'm trying to now visualize how this is built out and how people would use it for what you're proposing now. So when I'm just taking it from a stake pool operator's point of view, for example, when we're spinning up stake pools, we need to spin up servers and then we can run our stake pools that way. Is this something that is possible where stake pool operators could use the distributed computing power to run stake pools? Is that possible?
Yes. So again, well, I don't want to emphasize too much this difference between decentralized and distributed. Basically, yes. So what we are, in terms of the Catalyst project, which is Catalyst Fund 7 project, which is decentralized computing for the stake pool operators. So it's a part of, we are basically found a way to propose something as a use case on the early kind of, in the early stages of the network itself, and this use case pretty much uses certain fundamental aspects of the platform that we're building. And one of these fundamental aspects of the platform is that we can allow pretty much any application to find the computing resources through NuNet for running backend for that application. So stake pool operators is pretty much that. And since we are also integrating into Cardano network, this is this kind of ideal use case for us to move forward. Okay. The way it will work is that, so first of all, we allow Cardano nodes to run on the decentralized network, meaning anybody who would like to run, let's say, passive node would simply declare that they would like to run a Cardano passive node on the network, and they would just run it. Then, in terms of stake pool operators, then we are building a way for the stake pool operators to pretty much build a container of the stake pool and to just give the address of this, basically to upload this container to the NuNet network or to the NuNet front end, and then allow for NuNet to search for the appropriate computing device, which is sourced via this network from the community or from anybody who is joined, to run this workflow and to connect the actual stake pool operator with this workflow that is running somewhere on the network in a secure way and to enable them to manage it. So that is basically the idea.
Okay.
Which is pretty much a kind of an alternative of running that on centralized cloud, cloud engines.
There's always that conversation about trying to decentralize the Cardano blockchain, and one of the mentions that people talk about is how centralized the stake pools are on certain infrastructures such as AWS or DigitalOcean, for example. There's a lot of stake pools that are on it, and at any point in time, AWS could turn around and say, hey, we don't want Cardano-related services on any of our networks, and it could shut it all down. So all of these services you mentioned come from participants within the NuNet ecosystem, so community members that are providing the computing power. Is that correct?
Yes. So NuNet itself, we do not have computing power. We do not provide computing power except for the certain sort of buffer computing power, so that we can sort of provide certain availability of computing power. But other than that, we are middlemen of sourcing computing power from the community who has it.
Okay. So, for example, I've got this gigantic computer tower next to me. It's AMD Ryzen 5, blah, 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 whatever it is. So I can provide that computing power. Is that the type of computing power you're thinking of? Oh, okay. Oh, cool.
Exactly. So basically, we are building algorithms. So, I mean, let's say there's a way for you to download certain program, to join to the network, and then to declare what kind of how would you like your computer to be used, basically, by the network, in terms of would you like to receive NuNet tokens for the power that you provide, possibly how much. Also, would you like to receive them on Cardano network? What kind of workflows you would like to run, whether you would like to support Cardano network with a passive node, whether you would like to run, let's say, other stake pool operator software. Things like this. Basically, you will be able to say the preferences of how you would like the network to use your computer. Maybe just to use, not to do any machine learning algorithms which are related to defense industry or whatever. So the idea, the protocol that we're building is the ability to match the computing needs, let's say, for computing processes from, again, developers, communities, application developers, including the Cardano community, but not exclusively, with computing power that is pretty much on the desks of everybody, which is huge and unused, but also allow people to choose how they want to use this computing power, so that we can match those presence both in terms of the hard, let's say, hard constraints, meaning that the hard constraints is RAM, disk, CPU power, maybe GPU availability, etc., and so on, which is also important for the stake pool operators. They cannot run on any hardware. There are certain requirements, and also the size of the stake pool. With also these soft kind of constraints, where we can basically steer the network capacity towards certain, let's say, preferences of what community wants to do with the capacity. With, again, the computing capacity which is sourced out of the community. And community in this sense is basically the world.
Yeah. Okay. You've opened up even more questions for me here. So, like that level of granular control, where I can pick and choose what is actually using my computer, or who's using my computer for what reasons. That's really powerful, especially like you said, like nothing to do with defense. So I don't want my computer to be doing machine learning for the next Skynet robot that is going to take over the world. So that's cool that I can control those aspects and say only cancer research, for example. Is that what you're talking about? Is that granular level?
On the side of people who will be uploading the computing workflows through NuNet, then we, in the same way, we will ask to declare what kind of computing workflows, what is this, sort of. So, and then we will match. So what NuNet will do, will match all the hard constraints and soft constraints in order to search and match for the computing power. And of course, this will reach its, let's say, what I'm talking about is already when the network will be large enough, when we'll have enough people sort of connected with the computing power, and also enough people connected with algorithms. NuNet itself is both multi-sided platform and multi-sided framework, in the sense that we connect compute providers with algorithm providers, with application developers, with data sources, with data storage providers, into this framework where each of them can find each other and to contribute, sort of to compensate each other, to sort of distribute the value that comes from these workflows to all the pieces which actually contributed to specific workflows, like to specific calls. Let's say you have a program and you make a call to the backend. So we will have an ability to compensate compute providers for this specific call. And then, of course, so this is the most granular level that protocol will allow. But of course, we will be building certain sort of what do you call subscription schemes, etc., and so on, so that to make it most let's say accessible and efficient for all parties. I mean, for all parts of the multi-sided framework or marketplace, if you will.
This is very, very cool. Now, I had another question around the community or users that are providing the computing power. That would require me, like if someone was operating a stake pool and required my computing power, that would mean I'd have to keep my computer on 24/7. Is that correct? What happens if there's a power outage, I decide to turn my machine off for whatever reason? How does that compute power then, does it migrate to another user that's on the network? Would there be downtime? Obviously, I'm assuming there would be. How do those scenarios work?
Sure, there will be downtime. And so this is a kind of what's called part of the curse of decentralized computing. in a sense that there is a cost of decentralization when you do not have direct access to all the machines. Some of them go down, some of them go out of the network, and you do not have control over it. So the way usually it's done, and the way we plan it to do, is that we will have certain basically you split the tasks in terms of time and in terms of sort of space, and each time you try to cache all the data, all the computations that already were done, you cache them and you make them available through the whole network. So that if a certain computer which was doing that computation goes down, you may sort of restart the workflow on another computer and kind of download that data. Of course, it has a cost. All these things. So there is this overhead. There are quite efficient algorithms where overhead is quite small in within, let's say, basically single digit in terms of percent. And then, of course, some processes may not lend themselves to this splitting, and therefore, for those processes, you may need to have big machines. However, the conceptual architecture of NuNet basically allows you to also connect the big machines, or maybe even data centers, for certain workflows that are also declared of what they exactly need. Because another constraint on the workflow could be, time. Let's say that this needs to be done in certain amount of time, and if you want, and maybe with certain let's say availability percentage, which may be related to price. And if this is a requirement, NuNet may orchestrate it into the, let's say, big machine or a kind of a cloud or data center, where this workflow will be just done in a kind of on one machine. However, it will not be a headache of a user. It will be a headache of a platform, of a platform to sort of orchestrate these things depending on what is declared on the algorithm side.
Okay, that makes perfect sense, and I do like that ability to tap into a data center to make that work as well. If the data center is providing the compute power as well, so that's kind of paints a better picture for me to understand how a stake pool operator would use it, or any user really, to use the distributed and decentralized computing power in general. In terms of security, how secure is this in terms of using the network for something like a stake pool, for example?
Good question. And in terms of security, anytime when basically security is always a moving target, so you always have to work on security, and this is one of the let's say parts of the platform development, is basically the security infrastructure which is developed, which is evolving. So just concretely to say what we are thinking now for the stake pool operators within this scope of the project for the Fund 7 is, first, from the technology perspective, we are running containers, and then we containerize all the workflows, and then we orchestrate those containers in the decentralized network. So we allow those containers to be downloaded and uploaded, basically downloaded and then executed on pretty much any machine which is running on the network. And the way to do it is it boils down to securing containers from access from the host machine and securing host machine from access from the containers, which is basically we are building this kind of containers, and we moved away from, let's say, from Docker. So right now we are using Firecracker containers for that, which enable encryption. So basically, at least, I mean, I cannot guarantee because there is a lot of experimentation. So the tech team is doing a lot of experimentation. They try out, they backtrack, they see how it works. And we're looking in a matter of weeks, we're looking for the SPO, for the brave SPOs to try out, to sort of test things with us. So that, because then of course, SPOs know themselves much better what are their requirements and how would they like it to work. Therefore, we want to work together in order to sort of move this technology forward. But the point where we are now, we are thinking, so what we're building now is ability. So we'll provide scripts for the state pool operators to build their own containers and build their own pools, to put the private keys into those containers and to encrypt them with their own private keys, basically, so that nobody will be able to access. And of course, you may say, what about quantum computing? Well, this is something that, I mean, there are risks of encryption in general, which we cannot basically solve on our side. So we are using the technologies that are existing in terms of encryption, in terms of private public key infrastructure, so on and so on. And the reason why I said that security is a moving target, we are building this security so that it is at the top level in order to provide it at every moment. But yeah, so as right now, we will provide the ability to encrypt those containers and to run them on the network without anybody being able to access except the state pool operator.
Okay.
With the ability to sort of connect to those containers the way the state pool operators now connect, I guess, through SSH shell to manage.
Okay. So anytime you mentioned container, I was thinking Docker containers on there and, moving that around.
As good and sort of, Docker was the first and still the most popular, but it's not the only one and far from it.
Okay.
So we're looking basically at, we're using frameworks which enable us to orchestrate basically any containers and to connect those containers between each other. So let's say, we can connect the Docker container with Firecracker so that they work in the single workflow. Docker containers, Firecracker containers, and maybe something even on Metal, but we don't really use on Metal because it's not that easy to orchestrate.
Okay.
That just run directly.
I am so glad that you guys are putting this together and I don't have to deal with any of that level of security or complexity between different containers, operating systems and whatnot. It sounds like a very, very challenging project to work on.
And of course, sorry for interrupting. I didn't mention that, of course, all the communications are also encrypted and that is encryption is already on the platform.
That's good to hear as well.
Our goal and our let's say vision for the platform is to reach a place, and this is how we are sort of incrementally building it, where as all the decentralized system as basically where the entity which is building, which is made at certain point the platform will be run not by NuNet, but by the community which starts to contribute with the computing power to NuNet. And so we want to reach this level where we'll not be in a control, so that nobody could come to, let's say, NuNet headquarters and say, switch it off. And this is a kind of holy grail of decentralized computing in terms of the concept that nobody should be able to switch it off.
That is the ideal goal. So we've gone through the whole scenario of a state pool operator and being able to run a state pool through it. So we know that scenario. What about general websites and web hosting servers? Is that totally possible as well? And how would, I'm trying to visualize running an Apache server. Yeah, that should be totally fine. But how does a domain name flow through to DNS onto this decentralized computing service?
Yes. So from basically, if we strip sort of describe NuNet in a very simple, in one sentence, we provide infrastructure for running any computing process. Some of computing processes, they need, let's say, more computing power. Some of them, they need more storage. Some of them, they need more, let's say, RAM. Some of them, they need more bandwidth. Now, with Apache, you are correct. The main thing is to run, let's say, Apache server or whatever Nginx on the container, it's just not that difficult. What is more interesting is how do we reach that? Especially in a decentralized network where the computers, most of the computers will not have even IP addresses.
Yep.
Because they run, let's say, somewhere under, behind the network address translated devices, etc. And so on. So we have internal addressing scheme in order to find those computers in peer-to-peer way. Now, the access to the web in a completely decentralized way, it's not the question that we are only asking. It's I think IPFS, I would say they started it. Maybe I'm wrong. Maybe the most kind of. So the thing is, how do we translate from the current web, which basically works on IPv8 and tries to get into IPv6, which is not that easy still. When it will be at IPv6 level, maybe something will happen automatically because there will be a lot of addresses, so you will be able to kind of address each computer almost. But until then, we have to build some kind of gateways. So there are two ways, and by the way, Brave browser has one of the solutions which seems to be, at least conceptually, kind of a way to go about it. So they first of all have a public gateway, where if you enter certain address, which is, let's say, domain address, which is basically, I think this is one of the ways to use blockchain actually, is to put the domain addresses into the blockchain and to let's say put certain relay nodes where you can resolve those addresses if it runs on NuNet into NuNet. So the way NuNet works is that on each computer we install a NuNet adapter. And this adapter basically is a gateway to it's like a plugin to the internet. You just plug into the internet and it kind of starts to work. Of course, you also get an IP address and all the routing capabilities. So the goal is this: you install the NuNet adapter, and the NuNet adapter will resolve everything for you, basically. Which means if you are running Apache server and you have an adapter, on your computer, this adapter will resolve all the routing to your server. So people through the NuNet network will be able to reach this server, let's say. So one of the ways that Brave did now with IPFS, as far as I know, they give you two options. Either you install address of the public gateway, which resolves all the addresses into the IPFS, or you install the local small container or whatever, some kind of worker on your local computer, which does this resolving. So NuNet adapter does exactly this. It resolves all the addresses. So basically, but usually you don't want to kind of put this on user. So we either will have to build public gateways, or everybody who has onboarded their computer onto NuNet will be able to access NuNet directly and to access all the websites that are running on NuNet. Now, in terms of addressing, domain addresses, it's a kind of interesting thing. As I said, this is something that is blockchain, one of the use cases of blockchain. So we are interested to look around and to find these kind of solutions, let's say in Cardano, and to integrate into NuNet. I haven't yet sort of reached this because right now we're building the fundamentals of running the workflows. So the way NuNet working is that we're building a platform which is open source, and we allow this platform to use pretty much for any use case. However, we're also conscious that the platform itself is just a platform unless somebody uses it. Therefore, we are building it with an idea that with certain use cases in mind, so that people already can start using it. So this is SPO computing is one of them.
It really paints a picture of how the decentralized web and how the platform is going to be used in the future. I'm pretty excited about that. I come from a background of web development myself, so I'm trying to get that holy grail of a fully decentralized website where the images, the assets, everything is completely decentralized. And there's still a couple of little things that are roadblocks for me that haven't been able to fully get these websites completely decentralized. So it's almost there. And it sounds like if I can get a database server as well running on decentralized computing, that would probably push it a little bit further along the way.
It's a tough cookie because things that you need to solve here is what's called, usually we have location-based addressing of IP addresses, etc. You kind of, location meaning that there is certain geographical point where you connect, the server. And in this case, you will need something like content-based addressing, where you address content independently where the server is or where the content is. So basically, if you can have an address for a single, which is basically what IPFS is doing, right?
Yeah.
For each piece of content, like the JPEG image or whatever, and you address this content rather than the server where this content is, this solves. And one of the reasons why blockchain itself is beautiful technology. Well, the beauty is that it connects a lot of pieces. And also the Web3 movement is also kind of goes that way. It connects a lot of pieces. So the only thing that we can do, we can just move forward. Connect more and more pieces together. But I think basically the reason why answering your first question, why I got so much interested in the blockchain and in this space, precisely because of that, because it started to connect all those pieces, and it seems that all the fundamentals are there. But to get into something useful, in the sense that people can start using these technologies as alternatives to let's say established technologies, it's quite a mileage. It's
one hell of a mission, and at least we're having fun building, right? Every little roadblock and every little part that we're building out, it's a lot of fun, and new challenges, new engineering, and piecing it all together is part of the daily process of making it all work.
Yes, indeed. Engineering as such is fun, but of course, when you engineer something, you want it to work.
Yeah, come on, work.
Not just for engineering.
All right, so we've spoken about a whole bunch of things. We talked about the different scenarios and different components and different types of users that will be using the network. So the ones that are providing the compute power, such as my giant computer here, and also websites, SPOs on the other end, trying to use those computing resources. Now, how do people get incentivized to actually use the platform? You mentioned the NuNet token. How does the NuNet token come into play around the ecosystem?
Yes, so we have released utility token, NuNet utility token, and basically, as all the utility tokens, it's used for settlement of transactions between these sides of the multi-sided platform. So one thing is that so NuNet token is a cross-chain token. During the token generation, we released it on two blockchains at the same time. Part of it was released on Cardano, and part of it was released on Ethereum. The point is that basically here we also kind of extend this decentralization idea of decentralization, that we are decentralized there too. It's for users to decide. Our job is to build the APIs for the blockchain or technologies that serve this decentralized computing best, and also use cases of decentralized computing best. So one of the things that NuNet token will do, it will settle, simply speaking, transactions and prices between, let's say, somebody will want to run the backend of the application on NuNet. They will want to know how much it will cost, and they will, depending on what kind of workflow, it may need to be. Let's say if it's a web application, you need, let's say, 200 millisecond response time, kind of more or less time scale. If it's machine learning, again, depends on machine learning. If it's inference, you may want a few seconds. If it's training, you may be okay with a few days. But then you will have to reserve certain computing power on the NuNet network. And for that, we well, basically we'll have a smart contracts which will bind all these sites together and will negotiate the price of each of them and to settle them. So NuNet token will be used for settling them and for the microtransactions. Most of the things is for settling and to contributing to each part so that we can calculate, so that application developer so what we're building how do we call them? Dashboards. Where, let's say, if you're running, let's say, distributed web server or web application, you will want to know how much computing power you use and how much do you pay for that. So NuNet token will be used for that. Both to calculating and estimating for you how much does it pay? How much does that cost? Because in this sense, we'll have also to compare what is the price of running compute workflows via NuNet and with relation to alternatives like ADAOZ or all the things that we are running our compute workflows now.
Precisely. So in terms of the token pricing and working that out for comparison means, what kind of pricing and how much of a cost do you expect in compared to AWS for some of these, like a basic EC2 instance? So something like 2 CPUs, 4 gig of RAM. How would it compare in terms of cost compared to AWS?
Well, obviously we are aiming to be cheaper. So, but to say something concretely, I would not go there now. Because so there are two things that we are looking from the let's call it from the business model perspective. One thing that we're looking to run certain workflows on the decentralized hardware, and again, NuNet will not influence the price of computing resources directly. We will build a marketplace where we'll allow people to choose. That is the main thing, and by allowing more computing power to connect to it, which basically means we kind of move the computing market from the pretty much monopolistic / oligopolistic towards, let's say, well, not exactly perfect competition, but somewhere into more that, let's say, side, which simply opens more opportunities for people.
The way I see it is if the pricing is going to be competitive, you need more users on the network and more computing power. So the more it is, the supply-demand kind of situation. But therefore, we have incentives right now until we have the network scaled up to a place where it can support, let's say, because of course there is this scale economy, general issue, which is a law. We cannot. So until we move there, basically we have incentivization programs that we can incentivize people to join. The overall, I think in the beginning we'll see whether we can build certain ways to incentivize the computing power itself. In general, we would not like to incentivize computing power. We would like to incentivize processes that are running, because in this way we incentivize the development of the network. The fact that the network is big but doesn't run any useful computing which connects to the, let's say, value added on the application level, it may be good for the testing, but it's not good enough. And what I mentioned, that we are building use cases when the network is still small, in order to connect immediately these two layers, the users, let's say in this case SPOs, which we'll use, and the compute providers, which can already provide compute, and build this value flow. So in this case, why the part of the project is to work with SPOs to understand what kind of requirements are, and what also in terms of the prices, so that we can see what kind of compute resource owners we can incentivize or attract to this use case to join NuNet network,
and maybe to additionally incentivize them until the network is big enough to be sustainable by itself within this use case with SPO computing.
Very cool. That makes complete sense. That incentive to actually draw the users in those particular use cases, those workflows, to get them in and provide that power, and then build up the network that way. That's really cool. And of course, then you'll have more users, you have more marketing behind it. People know more about the network, and more people will join for other workflows and use cases as well.
Yes. So yes, actually, the network effects, you cannot run away from them, and however, we try not to rely on network effects.
Yep.
Or solely on network effects.
Yeah. One of the interesting things is to really get that price prediction of the costs over a long period of time. Like with any other centralized service, you know that you'll be paying X amount for a year every month. So it's really easy to budget in those particular costs. I'm seeing here, or I'm feeling, I don't know exactly, but there may be fluctuating costs month to month for using NuNet and the decentralized computing. Would you see that's the case in the early days?
Well, that's kind of a good question. I mean, good question in the sense that it's a challenge to make those things stable. In a sense, let's say, what kind of example would be? I think oil prices is kind of an example, right? They're fluctuating.
Yeah.
Nobody holds them in one place, and then people have to adapt. Now, and that depends on kind of supply demand, right? The goal, and this is I can say in terms of internal tokenomics. So what I sort of divide two aspects: internal tokenomics and external tokenomics. External tokenomics is let's say price of the tokens where people can exchange them, etc., with other tokens, etc. And internal is how exactly that settlement layer works inside the platform, and how do we connect the token amount of tokens with pretty much this physical entity of computing resource or compute power or right teraflops, however, whichever unit we choose. And that obviously has to be stable, because otherwise it won't be. So this is, by the way, this is one of the kind of conceptual, I mean, it's basically larger than NuNet. I think the whole blockchain or crypto space is dealing with pretty much that problem: is how do we enable people to use these technologies in order to buy, sell goods or services. And one of the reasons why it's not getting adoption is because of the price volatility and the volatility of inability to predict what you will get, and this is just bad for business. So it's larger than NuNet. And then you get all the stable coins, etc., and so on, so forth and so forth. But one of these more conceptual goals of NuNet is provide this layer of connecting crypto space to the physical space or units, which is computation. Which is, I mean, computation itself, the price of computation itself is not stable. It's stably reducing, let's say. There is a kind of a law, but then again, it depends on the semiconductor industry and where can you reach, and so on and so forth. GPU prices are not stable. They're jumping.
No. And I know that from personal experience. My GPU died recently, and I have to pay almost 3 times the amount that I did for a really high-end, top-end card, a few years ago. So it's very painful. But I know exactly what you mean there. And it's very hard to keep this stabilized.
You relate to pretty much fundamental questions which are solving within the platform. So one was security. Ability to connect to decentralized network and to the addressing issue and to find let's say resources in terms of web services. And another one is this one, which is the whole economics and how do we sort of stabilize it and how do we make sort of prediction on top of it. One of the ways to do it, and of course in the beginning we'll have to do it probably through the incentivization, etc. and so on. But our goal is to gradually and as fast as possible to reduce it into the, let's say we can have certain staking schemes or certain, let's say staking based on stable price for computing resources on NuNet. So that could be ecosystem from the economic perspective, an ecosystem where people will jump in and pool resources or maybe stake some kind of resources for providing stability within the network. But that is already an economic perspective, which is again another part of NuNet, which we will building.
I think I've really pulled apart NuNet at the moment and really dived into certain aspects that thankfully you can answer all of, so which is fantastic. But probably the more pressing one now is that now that people have heard about it, people are learning about it, when can we actually use it? What does the roadmap look like? Where are you at with development? I can see the fancy dashboard behind you as well, and that looks like probably the marketplace. Where are you at with everything, and when can people actually start using the platform?
Yes, so the fancy dashboard is our MVP, which is basically the MVP. We are allowed to use basically web app which runs on the mobile phone where you see, and then we had the dashboard which shows what kind of processes are running on the whole network. Basically, the roadmap, we have now a roadmap for 2.5-3 years. This roadmap is general epics of what kind of features we want to build, but quite soon we realized that we have to rebuild reprioritize the roadmap based on what kind of users we get. Since let's say, and we kind of reprioritized, as I said, the roadmap in terms of the current demand. So, for example, Cardano nodes, we were not thinking about them when we were sort of building the initial roadmap. However, the features that we built into the initial roadmap cover that. So we sort of reprioritize them based on what, because there is a current demand, and it seems that it's something that we will build within this year. So the project is 7 months. I really hope that we can start offering, at least on the test net, and maybe on the production net earlier than that. But since I'm very conscious of what are the challenges, and especially in terms of security. But basically the roadmap gets resynchronized based on each use case. So we have a general roadmap of coming to a place where we could offer, let's say, offer different users or different application providers or different communities to try to, not even to try, but to already use NuNet as a platform for infrastructure without, let's say, doing pilot projects, testing, etc., in a couple of years. Right now, we want to go forward with specific use cases, like SPO computing, which is now timelined at 6 months. Maybe we will come up with shorter use cases, like, for example, it seems that running Apache servers should be easier, maybe. Should be. However, there is this, it should be, there is this, gateway issue, but it's basically everything is in place. So in that sense, we are not building business processes ourselves. So we are searching for people who would like, or who see the opportunity, or who would like to work with us in order to enable certain application logic to run on NuNet backend. So, and then we take this application logic, we define the requirements that are needed on the NuNet side, and then we implement those features for that logic to run. And that may be in months.
Okay.
So this is how we prioritize the platform. And I think this will enable us to move fast and not to wait until everything is there in order to offer it.
Okay, so in terms of community then and engagement with people and getting feedback in regards to particular workflows that may be implemented, is there a way that the community can engage with you? Do you have Discord servers, Telegram servers where you can talk to users and get ideas for some of these use cases and workflows to implement within the platform?
Yes, so we have a few, of course, all the Telegram channels and things like this for immediate communication. Then we have Dev Exchange server, where people more into technical, let's say, it's something like Stack Overflow, Stack Exchange, where people can put the ideas which other people can pick up and see whether we can build anything out of it. Then when we find through any channel, so then we have Medium blog. Our issue queue is open. Basically, all the development which is going on both on the Git, we are now on the GitLab, and we are sort of pretty much planning to stay there. So all our code is open, all our issues and issue queue and issues and epics are open. Right now they're accessible through Jira. On all of our blog posts, we link all the we put all the links through which people can access us. And also we are now started a few weeks ago this initiative of tweeting all our technical developments with the links to the issues that cover them. And that basically, so we are inviting people to join in terms of also from the development side. So if, let's say, anybody sees certain epic or certain issue or certain story that makes sense for them in terms of, let's say, to run the application or to run the workflow, please contact us. And then we also have this sort of program where when people contact us, we start building use cases with them, because it's also certain mileage to structure the use case. And we try to do this as open as possible, meaning that on open GitHub repository, where everybody basically can see what is being built. So if you see something interesting, some kind of feature interesting that may work for you, or that can work for anybody, please contact us through any of those channels, and we will start building this kind of structure for the use case.
Okay, brilliant.
And then we will prioritize these features, this epic of the story, in order to build it up to use.
I did flick through GitHub and had a look over some of the repositories, and you guys have been very, very busy, that's for sure. And it sounds like you have a very agile development workflow as well, using epics and stories as well. So it sounds like you can adjust on the fly as you go through and discover new use cases and prioritize, as you said. So that's absolutely fantastic. That's really good. And I'll make sure I put links to all of those touch points in the video and the show notes, so that anyone that wants to reach out, learn a little bit more about the project in those respects, can do so. Now, lastly, I want to talk about partners and other entities that you've partnered up with. Looking over the website, there's some really big names there, and I'm assuming you would have built up this relationship over the last few years when you were building this out. Can you highlight some of the partners that you've got on board and how are they involved within the project itself?
So the main one is, of course, SingularityNet. And the relation with that NuNet is a spin-off of SingularityNet. So SingularityNet has been incubating NuNet for a couple of years now. And as I state that, so just connecting a little bit with your previous topic, is that the state where NuNet is that we launched a few months ago, and we are in a state of heavily expanding our team and building the team. So and we are trying to build it immediately from this agile perspective. So without waiting until everything is nice and sort of structured, we're already putting it out to the community to see what's going on. But yes, we have a lot of open positions, and we are building the team as we go. And we will be continuing to do this also because we develop based on use cases, and each use case needs additional people and additional skills and additional talent. So this is the state where we are now. In terms of partners, yes, as I said, the main partner is the SingularityNet ecosystem, and there is both from the business perspective and also from the technology, like from the tech perspective, because the first thing that we started in our MVP and what we are going to develop is to run SingularityNet AI services on NuNet. So this is one of the important aspects of NuNet and how we came up with NuNet in the first place as an idea. So then the whole ecosystem, which is now, and SingularityDAO is also a spin-off of SingularityNet, and what we call ourselves is that SingularityDAO is DeFi arm of SingularityNet, and NuNet is the infrastructure arm of SingularityNet.
Very interesting, very interesting. It's really cool to see the ecosystem evolve that way as well, and these little spin-offs evolve and grow to where it is now. So it's getting there. And I did have a look at the jobs page, and you guys do have quite a few hiring positions at the moment. They're mainly EU positions.
No, they're global. They're global. We are completely global in this sense. Of course, there is this time synchronization issue, but I think everybody has this issue now, so it can be dismissed as not an issue.
Yeah, that's what I was getting at. I saw time preferences on the jobs between particular time zones, but people here in Australia.
More, I mean, it depends on which kind of job. For technical jobs, for sure, it just doesn't matter. And of course, there will need to be certain synchronization. Okay. I think it's everywhere written that it's global. Remote global.
Anywhere you have an internet connection is totally fine.
Yeah, so we are more thinking about skills and motivation and the connection to the vision rather than time zone. What we are thinking as NuNet is that NuNet is a kind of core developer. So, core developers means that the ideal would be that, depends on how lucky we are in terms of management, is that it's like an open source project where most of the contributions come from the outside developers rather than the developers which are within the team. And within the developers which are within the team, they will integrate everything. They will build the CI/CD and all the pipelines which will be needed in order to guarantee that the platform is actually secure and nothing breaks it. But we are looking to leverage the community power also from that side. So it's from kind of multi-sided also in this sense, because it's not only that there are a lot of computing resources scattered around the world. By the way, mobile phones is another step that we will go in at a certain point. GPUs is something that we already getting into slowly. It's not that only the computing power. There is, and when we get into mobile phones, there is data comes into play, where from the computation perspective, data is part of computation. So you cannot just say that it's just only CPU, let's say. But what I'm getting into is that in intelligence of community and the knowledge and skills is also these resources which we want to leverage within the whole ecosystem.
Very much so. It's a broad range of people brings broad range of skills, and any experience contributing to a platform like this is, really, I guess, really appreciated. especially when you're trying to build out an open source project, which I've worked on so many of. The really passionate people you want contributing to the projects that way.
Yes, so just a note, apart from the technical roles that we mostly described in the job space, we're also looking for people who may, let's say, want or see the opportunity to help us developing Decent as an open source project where community is the main driver of it, rather than the core team which supervises or sort of guarantees that certain processes within the team. Within the whole platform.
Well, thank you so much, Dr. Kabir. It's been an absolute pleasure talking to you about the platform and learning more about NuNet as well. I think I threw some really hard questions at you, and thank you for answering them as well. But it's really good to dig deep into a platform like this, especially if the broad scope and the amount of people that could potentially use this is absolutely huge. So I'm really looking forward to this one coming out, building out, and getting my hands on actually using it as well.
Thank you. So first for inviting, second for the questions. It was fun answering.
Brilliant. Thank you. If I could actually host websites, basic websites, advanced websites, React-based websites, whatever on this platform, I could really utilize that and really incorporate it into my business practices. Even little things such as build processes. So when you actually build a website, if it's a React website, for example, or anything that's built in the modern web age, you go through and use server resources and build out the website and only use a server for maybe a couple of minutes. If I could use someone else's development environment and tie that into some of the build processes there, and deploy it to the cloud, that will be really appealing. It has a different option, a different alternative to what I'm using at the moment. And that's pretty cool. And having that all decentralized and using tokens and whatnot to actually pay for it, it is a little bit more appealing for me. So this is something that I could see powering the decentralized web, the Web3, that missing link. So we've got the wallets, we have the blockchain, but what about the actual website interfaces as well, and the computing power that actually powers a website? This is part of that missing link that is needed to fulfill the entire decentralization of the internet and everything behind it that's powering it. So I'm looking forward to this project, if you can't tell. Hopefully it comes out very soon. I can get my hands on it and play around with it and find out what kind of workflows we can actually deploy and have actually working for websites and whatnot. So fingers crossed this comes out very soon. I'm looking forward to it. Everything that you need to know are in the links down below in the show notes and descriptions. Now, if you really like this content, please consider giving me that thumbs up, click subscribe, click on the notification bell, and you hear more great Cardano content from me. I'll catch you in the next episode.
Yeah, gotta do it like that. You've been listening to the Learn Cardano podcast. Gotta get it hype. Crypto is what we like, but this is not investment or financial advice. Gotta do your research, cause it's risky. We know it is. This show is educational and it's informative. Crypto's the future, really, it ain't no debate.